Okay, so this is our second lecture in software design 2 using Java. So I kind of want to pick up. So last lecture, we really just went over the syllabus and we very precisely and articulately went over the learning objectives to give everyone a good frame of reference of where we would like to end up by the end of the semester. So I kind of want to do the inverse of that today and ensure that everyone has a strong understanding of where we should be starting at. So typically, for the first couple of lectures on our tentative schedule, we have a refresher where we really kind of delve into inheritance and polymorphism. Now, I had talked a lot about it at the tail end of last class. I think I spent the last 10 minutes just very quickly rapid firing of the difference between like concrete classes and abstract classes, interfaces and abstract classes. But I think there's certainly a distinction between understanding in principle or theory something and understanding it in application, and when one would make a decision on when to do that thing. So I think what I'll probably do today is we'll actually step through some code, and hopefully code that you did in 1583, and just make sure that everyone is feeling pretty confident and comfortable with what's happening there. And if not, please send me a message and we can kind of articulate the concepts more so. But I just want to make sure that everyone's on a solid grounding from where we last left off before we pick up moving forward. Excellent. So before I start the lecture, does anyone have any questions? Okay, perfect. And of course, if at any time you do have a question, please just drop that into the Zoom chat. I have that open so I can see that. I think, let me see, as I like move around, let me see if it, oh Lord, doesn't move around with me. So I wish there was a way for that. Oh, that's okay. What I might just do is open up my IDE over here. Well, okay, so anyway, let's get to our example. So let me first start off by asking at the tail end, or maybe not even at the tail end, but at some time during your tenure in 1583, did you walk through the example of making a employee and a like salary employee and like a commission employee and like an hourly employee? Perfect. And then did you then expand that to include something like a interface, so that if you had something like a let me see, something that wasn't an employee but still had to be paid by the company, you could go ahead and implement an interface for that? Okay, so I see some no's, I see some yeses. So I'll make sure that everyone has a strong concept with that. So why don't we see what it's like to actually step through there's some code, and that's going to dictate whether I live code or I just open up code files and I talk about what's happening there. So we're going to see how good I am at typing, and that's going to dictate the rest of this, the rest of how the future lectures will go. So let me start off by saying that before we drop into the code examples, in 1583, we purposely use the terminal so that you get a strong understanding of having to navigate your system from the command line and understanding how you can execute your applications, such as the JDK and the JRE, from the command line without having the need of any supplemental tooling. It's very important that you understand how to, what's happening behind the scenes, and that the way that your code compiles and then finally executes isn't done by some magical application. This is something you can do by hand. But now, again, the goal for this class is to start introducing you to some professional tooling, and professional tooling is usually used inside of what's called an integrated developer environment, or an IDE. So I'm going to start using a IntelliJ, which is one of the most popular IDEs that's used for Java. So I would recommend that you also go ahead and install IntelliJ whenever it's convenient for you. I think it would behoove everyone to get comfortable with starting to produce code inside of a IDE, but I think it also behooves you to be able to produce code at the way that you have already learned from essentially the command line and from just a simple text or code editor. Yeah, that's right. So it's Jetbrains who does that. And in fact, they have a community edition. In fact, if you log into your web terminal.cs.uno.edu, has everyone been shown this before? That we actually host a, now if you want to install it to your local machine, you can go to JetBrains, and the community edition is 100% free. And that's under any kind of short-term things. It's always free. In fact, if you want to graduate and end up using Android Studio after this class and start building mobile apps for Androids, which I think you should definitely try and attempt to do after you're done with 2120, Google had selected IntelliJ as their code editor, their IDE of choice for Android Studios. So if you download Android Studios, the basis of that is IntelliJ. Now, just to promote the other IDEs out there, there's also Eclipse and there's also NetBeans, and they're all popular. But I'll say IntelliJ, from my communication with a lot of industry members, is probably the most popular I've heard that is used professionally. And so actually, so if you come into the web terminal, if you click on applications, there's this programming tab, and you'll see that we actually have IntelliJ IDEA community edition available. And so I think it might take just a few moments. I'm going to be using the local edition, but it might just take a few moments for it to initially load up. And then once it loads up, you're good to go with it. So I'll load it inside of the web terminal just so that you can see what it looks like. Yeah, it does look like it takes just a moment. Let's see here. Let's try that again. Let's make sure that it got my. Okay. Oh, I have to confirm that I've read and accepted the user agreement, and then I can hit continue. And let's not send any data sharing. And now we're actually loading up. Oh, and there. That's pretty quick. Much better. You just have to agree to the EULA. Okay. And then, of course, I see that the web address, and for those of you watching this later, we can go to JetBrains IDEA Community Edition, and right here there's a download section. And what's great about this is they have it available. This IDE, this integrated developer environment is available for Mac OS, for Windows, and for Linux systems. So no matter what platform your OS is on, you should be able to go ahead and install this. And it brings together a lot of cool tools that'll make developing larger scale projects much, much easier. And so there's things that we'll try to touch over the course of this semester. Like I would love to teach you some of the build tools like Maven or Gradle. We can integrate our version control into this. We can go ahead and use a debugger. So I would definitely, if we have time towards sometime during the semester, when we get into testing, I also want to show you debugging. So there's a lot of tools to be able to help you build code faster and to test it and to validate it, and just to make sure that you can reduce the amount of time it takes to create your projects. So I have a question: is IntelliJ a better option than Visual Studio Code? Well, so that's a great question. Visual Studio Code is, for the most part, it's a lighter weight editor. The big thing about IntelliJ is that it's the most dominant IDE for Java development, to the point that now Google's heavily invested in Java, right? Because Android was written in the Java programming language. So I think it speaks volumes that they had selected IntelliJ to build Android Studio around. So VS Code is great, but keep in mind that that's a Microsoft product, and Microsoft's specialty is in C#, which is a direct competitor to Java. Now, I'm not saying that that really affects your ability to program in Java. It's just that's not going to be their priority when they go and develop the editor. So for instance, if we were doing .NET, then we wouldn't just use Visual Studio. I mean, IntelliJ would be closer to not just Visual Studio Code, but Visual Studio, the full platform, the full IDE. Okay. Which I think, has anyone taken assembly yet? Do they still use Visual Studio to author assembly code? Well, if not, if so, then this gives you an opportunity to be able to compare and contrast between IDEs. Excellent. Okay. Well, I guess that makes sense because this is 2120, and I don't think they do assembly over the summer. Okay. Okay, so let's see here. Where was I? So we're here. We're here. Okay. So let me. Okay. So let's see if so. I'm going to go into IntelliJ. So when I first launched IntelliJ, it's going to bring me to this welcome area. So I guess I'll give you a quick walkthrough if we're going to build some code in here. And in fact, why don't we, so all we're going to do, at least for now, is revisit that employee code so that we can really talk about it pretty deeply. But you know what I might do here? Let me quit it here and let me open up IntelliJ here so I can still see this chat. So let's open my application. So we'll launch IntelliJ. And so what I'm going to do here is I'm going to select a new project that's in the top right-hand corner here. So let me click. Okay. And so I'm going to give my project a name here. I'll just call this a refresher on 1583 or Java 1. Instead of using magic numbers, we'll use a better descriptor. Refresher Java 1. Okay, so this is going to be the name of my project, and then it's going to have the option to select a location where it's going to save your source code files into. By default, when it's installed, when the IDE is installed, IntelliJ is installed, it'll create a IntelliJ projects directory. I'll just keep using that. Notice I even have the option to create this as a Git repository if I wanted to. Here, the language I want is Java, but the JVM supports more than just Java. Not that that's super important in this course. Other languages, for instance, would be like Kotlin, which is another popular language used in industry. And you could actually convert Java code into Kotlin code or Kotlin code into Java code. Our build system we're going to use is IntelliJ, but notice it allows us to build our projects using alternating building tools, which is something that is worth knowing about as part of our tool chain, because we can define what technologies your source code rely on inside of these build tools. Like if you use a specific version of Java, or if you have multiple class paths that you have your dependent code in, we can define that in a build tool. So again, super popular in the industry world and not so popular in academia because we don't build projects that are that large. And then this allows us to select our JDK. Now, you probably have Java 17 because that's the LTS, but I'm a maniac and I'm on the experimental Java 18 right now. Okay, So now let's see here. Let's go ahead and create this project. And so what's going to happen when I first launch this, just let me stretch this out so it doesn't look like it's part of my browser, or I don't actually confuse my browser with my IDE. Okay, here it's just letting me know that I'm using an experimental version of Java. Let's just exit out. So look, it's giving me an alert. That's perfect. So if I didn't know that I wasn't using the LTS version, it's giving me an experimental feature alert. Okay. So here on the very left is a pane where I have my project that I just created. And you'll notice there's a couple of things that are worth looking at. It creates a .iml file. Let's see what happens if I open that. So if I open that, you see this is the configuration information for my project. So this automatically generates. I don't really need to know how to do this, but guess what? It's worth knowing about just so you know it exists. So when you go into an IDE, so when you start hearing things like build tools, you know effectively what it's doing. So since we generated this project inside of IntelliJ, it's going to auto-generate this IML file, which is going to tell IntelliJ how to start up our project. And so this allows us to have like different versions of Java, for instance, for different projects, if necessary. Okay, and then all of the IntelliJ secret stuff will go into this dot folder. Dot folders are typically like private or hidden folders. So again, this isn't for us to know about, but I'm just letting you know this stuff is auto-generated for us and it's to track your project. Okay, let me close this. I don't care. So all of our code is going to go into SRC. So that's going to go into our source code. So now let's do this. Let's go and I'm going to select to create a new Java class. Perfect. And so I want to say when we built this employee class, let's talk about some modeling principles. Let's make sure that everyone's on the same page in terms of how we initially defined this code in 1583. So when we modeled an employee, what were some of the attributes that define an employee? I want to say it was like a name, right? Let's see. It was a name. And so it was a first name. It was a last name. And it was like a hire date, right? And so if we want to have a hire date, well, that's not easily represented by any of the built-in data types that were given, right? So if I think back to the primitive data types and string, which is a reference data type, but for all intents and purposes, it's built into Java, very similar to a primitive data type. In fact, it's imported with a module. So let's actually take a quick look at that, just to make sure that everyone is understanding what's happening with that. So let's look at string in the Java Oracle API. So if I go here, because right, everything with a capital letter, right, we clearly have something called class string. So it's not technically a primitive data type, but I'll see it's part of this module java.lang. And so notice you can use strings without importing java.lang. It's because java.lang is implicitly imported into every Java source code file because it represents the Java language module. So again, java.lang is also where, guess what, objects are defined at. And let's see, does it even let me go to the top level? Let me see if it lets me go to the top level of just lang. Let's see. Okay, so here, let me go to just java.lang. So here, yeah, you can see all of our, did you talk about boxing and auto boxing in Java 1? Is that a term that sounds familiar? Okay, so we'll talk about that later when it actually makes a little bit more sense. But understand, so did you cover the concept that everything that is a reference data type, which means it's built from a class. So every reference data type is built from a class definition. So okay, perfect. So if every reference data type is built from a class definition, then they all inherit from the grandmother of all classes, which is the object class. So the object class is the root class by which everything else is inherited. And so you covered that that Java is single inheritance. Yes, so like one Java class can only inherit from one other Java class. So so this is the thing, if you're not explicitly inheriting from another class, then you're implicitly inheriting from object. Is everyone pretty confident or comfortable with that? Okay. So object then is actually defined in java.util. Now, exactly. So what I'm building up towards is there's a kind of a problem that we have in that sometimes we want to be able to treat everything as an object, but the primitive data types are not technically objects. They're not technically reference data types. They're primitive data types. Does everyone kind of understand what the true distinction of a primitive data type versus a reference data type is? Like, I know that we probably covered like some of the symptoms, like primitive data types always have they always use like a lowercase value, and the reference data types always use an uppercase value. But let me ask you this. Why do you think a string has to be defined as a reference data type and not as a primitive data type? Why are ints and doubles and chars and booleans allowed to be primitive data types, but strings, which are a very fundamental component, we introduce them almost the same way as the other primitive data types, but we have to make sure to illustrate that it's a reference data type. What do you think makes strings different than the actual primitive data types? Does anyone have any clues? Anyone has any guesses? They're not numbers, but it goes a little bit beyond that, right? Like, I guess you could say that cars are kind of defined as numbers, but they kind of exist in this middle ground where they exist kind of as a glyph, and also it has like a character. It has a character code. Or Boolean, technically true and false, so they're not numbers, although you could represent them as a zero value or a non-zero value, which some other languages allow you to read Boolean values as, but Java is not one of those. No, that's a good guess that they're not numbers, but it's actually a little bit different, but it's kind of tied to that concept. Let me ask you this, because I'm going to motivate the solution with this question, I think. What is the difference between an int and a long? That's right, the size. So let's see what what is the max size of int in Java? Let's look. Oh no, I kind of knew what I was talking about. So my max sizes of an int is between integer min, integer that, and let's do long so we can see here. And so the reason why we have these different sizes is because one is encoded in 32 bits and the other is encoded in 64 bits, right? Did you kind of cover that concept, that your ints are encoded in one memory size? Perfect. And so then you understand that double is double precision on floats, and you always want as much precision as possible. Okay, so what that really means is there's actually a finite number of int values. There's also technically a finite number of double values. There's also a finite number of Boolean values. There's a finite number of char values. Actually, with every primitive data type, it's a finite number of values, right? So even though we like to think of numbers as being infinite, ints don't represent an infinite set of numbers. It represents a subset of numbers, a whole lot of them, but it's limited on both the negative and positive side. And then if you need more than that, then you have to go to long. And then if you need more than that, well, then you have to go to something like a big integer. So the idea here is that a string, right? Now think about what a string represents. A string represents text. So there's no way to have a limited number of text built into the JVM. By predefining your numbers or your booleans or your chars, that can be hard coded as actual values, right? So it's not something that's just in memory at the time that your application is running. The JVM can just look directly to that value that's hard coded into the system and get that value. And that's what makes it primitive, right? That it doesn't have to exist in memory, that it actually knows that value internally. Now with a string, strings can be the amount of the amount of permutations for letters is so large that there's no way to represent that as a finite set. And so that has to be represented as a reference type. You can only know a value of whatever string should be saved by putting it into memory. So does that kind of motivate everyone's understanding about like really the difference between a primitive data type and a reference data type? And of course, when we say reference data type, what we're really referring to is it's a reference in memory. So every time we need to get that value, we have to go someplace in memory to pull that value out of. The JVM doesn't automatically know that by default like it does with the primitive values. Okay, so just making sure everyone's on the same page with that, then we have a problem, because then the primitive data types aren't technically objects, but we want to treat object as the root of everything. So that if I create like I'm sure you've seen this. Let me actually show this off. So I should be able to do this. Let me create my project. So let me create a main. So I'm going to create a main class. Okay, so I'm sure, let's do a public static. Now I can hit tab and I can autocomplete in this. Public static void main, I'm sorry, main. Okay, perfect. Yeah, let's do that. Args. Okay, so let me define a main method here. And so have you seen this? So I can create an object array that I will just call things. And then inside of there, use like an initializer list. And I can put something like the number 1. I could put true. I could put a string. I could put a double, right? I could put a car. Okay, and now let's do this. Let's do for, let's see, object I in things. Well, let's call this item. Let's be a little bit more explicit. Okay, so we'll use an enhanced for loop. And let's just do a system.out.println. Let's print out that item. Okay, so here's just a basic source code, right? So I have an initializer list of a variety of things. And one of the important things about everything coming from object, being a member of object, means that I could put anything. I could put other instances of classes in here. And so since everything's a member of object, I can hold in this array and then iterate and print it out. And then if I go and hit, you see this little green arrow here. I can run my code. I have the option to run. I can also have the option to debug. We'll go through debugging later, but let's run this. Okay, and here it's going to produce my output right here. And look, I print out 1, true, hello world, 3.17, and A. So clearly, I was able to run this code without any issue, which means that all of my primitive types can also be treated as reference data types. And the reason for that is because of auto boxing and boxing. So what happens is what the JVM does is whenever it sees a primitive data type and it should be treated as a reference data type, it automatically boxes it, that value, into a reference data type as defined inside of the Java .lang module. So notice they have the capital B for Boolean, capital B for byte, capital C character that represents. So for instance, this Boolean class wraps a value of a primitive data type, Boolean, into an object. And so an object type of Boolean contains a single field whose type is Boolean. So it now allows us to treat primitives as if they're reference types so that I can get the behavior that I would expect Java to allow me to, which is to treat them as objects. And then at the same time, instead of having to do like a dot equals on them or other reference calls, it can automatically unbox it and treat it back as a primitive. So that's what boxing and unboxing has to do. I kind of forget how I got onto this big detour, but it is relevant. Like, this is an important thing to know that Java is doing behind the scenes. So I'm glad that we took the time to kind of explain it, but also why java.lang is implicitly imported into every Java source code file is because it needs to be able to potentially unbox or auto box any of your primitive data types. It needs access to all of the methods that are defined inside of the object type. It needs to know what a string is, right? And so you can see there's a lot of pretty powerful classes that are automatically defined. Like math, for instance, was one that you probably used in Java 1. And again, it was probably unlike the other classes that were part of the java.util, because java.util is not implicitly imported. You have to explicitly import it in order to gain access to those classes. So eventually later on in the semester, not too much later on, pretty soon, we'll talk about modules and how we can define our own modules. But java.lang is, I think, the only module, at least that I'm aware of, that is implicitly imported without you having to create an import statement. And it's because it has some very fundamental classes that are required by the Java language to actually work. Okay, so with that said, I think the entire motivation behind all of that, though, was to say if we wanted to model an employee, right, I can't just and actually, why don't we start doing that? Let's model employee. Let me create a new. So I'm going to go here to source. Now notice, before I do that, I want to highlight something in the IDE, since this is probably your first time kind of navigating through IntelliJ. After I've compiled my code, notice I now have a new directory that's called out. And if I unpack that, you'll see I now have a production folder that has my project, refresher Java 1, that has my class file for main. So as I compile my code, all my class files is going to go into the code directory, and all of my source code is going to go into the SRC directory. So I'm going to go back over here. I'm going to click new. Let's do a Java class, and let's do this in real time, because this is all old stuff, so I don't want to spend too much time on it. So let me click on class here. So we're going to create an employee class. Oh my goodness, I already misspelled. Okay, you know what? Let's just delete that. Oh, okay. Let me do this. Where is the rename? I think that is right there. Okay, rename employee. Yep. So let's go here and remove that X, and I'm going to refactor. And so any place where I actually had that typo, when I go into the option and refactor to rename something, it would have corrected that for me. So again, that's one of the beautiful things about an IDE. If you make a misspelling and you recognize after the fact, it'll actually change it across your project. Okay, so now I have an employee. So the first thing I do when I define an employee is I have to determine what its attributes are. And so we use our instance variables. So we'll have like a private string, let's say first name employee. We'll have a private string, let's say last name employee. Highlights, again, when I do a typo. Okay, perfect. And we also said that our employee, if I remember correctly, from 1583 had a date, right? And that is supposed to represent a higher date. Now, if we wanted to do a date isn't a primitive. That's how we got on the tangent, right? We were talking about using other classes we built inside of the class we're currently defining. And so this is has a relationship. So this would be composition, right? So when we have one class that relies on another class, and it has as one of its attributes an instance of another class, we say that employee has a instance of date, which is completely different than the is a relationship that one has when it inherits, right? So because employee is not a date, it just has a date as one of its attributes. So, well, I can't do this because date doesn't exist. So let's go and define a date. But I guess before that, let me just continue with this really quick. Now, it's giving me the option. Notice the IDE is giving me the option to say, hey, I found the date class. Do you want me just to import that? I'm going to click just to show you. If I did this, I could just, let's see, this and enter. If I did that, it would go ahead and import. I'm not going to do that though. I want to create my own, but I can do this. Let me right click. I can go down to generate. Let's go to generate. I want it to generate a constructor for me. Yeah, I want to use all these parameters inside of the employee, and bam. So again, a nice thing about an IDE also is that it can auto-generate all the kind of the boilerplate code that you find yourself typing out a lot. Let me do this again. I'm going to go back to generate, and I'm going to say generate getters and setters for me. I'm going to select that I want getters and setters for all of these, and then I'll just hit OK. And then there I have a getter and setter for all those. So again, I think there's a great value to doing this all by hand in 1583. But I think there's also a great value once you hit 2120, where you could see how real developers are actually generating Java code, where you're not spending a lot of time working on building things that are very simple. Okay, so now I still have this problem. Notice that my date is highlighted red, and I'm getting all these like these red lines here, and so it's letting me know it doesn't know what date is. It's giving me the suggestion it cannot resolve symbol date. And so it's letting me know here with the squiggly red that this class is broken. It won't compile if I try to compile. Okay, that's fine. So the next thing I'm going to do here is let's make a date class. So let's go to here, Java date. You're feeling duped that we didn't show you IDEs earlier, huh? Well, how about this? You're probably the only section who's going through with IDEs. It's my understanding that all the prior sections were still using the command line. Okay, let's see. Let's create a date. Okay, so what are properties that define a date? Well, I think we can all agree that a date would probably have be defined as a year, it'd be defined as a month, and it would be defined as a day. And these things, all of those attributes, can be represented as, here, let me do this, attributes for a date. All of these can be represented with a No, not with caps locks on, with a primitive data type. So a year could be represented as a primitive, a month can be represented. Oh, I kind of wanted it to actually spell out month. Tab goes wrong. And then the day. Okay. So here, I won't need to rely on other classes, but notice one of the things that happens while I'm developing my code is I sometimes realize when I need to build another class, right? Like I didn't necessarily know I needed the date class until I started modeling the employee class. And while I was modeling the employee class, I recognized I needed a date, and I could have. It is possible I could have created an int that represents the year. I created an int that creates represents the month, and I created an int that represents the day. And I could have put that in employee. But why would that be a bad idea? Why make the date class when I could have done this, right? Wouldn't have this been easier to do, because now I have to build this whole nother class? Yeah, so one instance of that is all very great answers. You'd have to retype that for every class that needs a date. It's not modular. How would you do the date format? Well, if I wanted to do a date format in this, then all of a sudden, all of the logic, if I embed the primitive data that govern a date inside of employee, now all of a sudden an employee would also be responsible for knowing how the logic for dates work, right? And that violates one of the principles that have us develop our class definitions. So in this semester, we're going to start to cover what are called the solid principles. I'm sure you started covering what were called the dry principles in 1583. Am I correct in that assumption? Did everyone hear the words like the dry? Okay, perfect. So in software development, there's a concept that's called developing dry solid code. So last semester, you learned what it meant to be dry. This semester, you're going to learn what it means to be solid. We'll have an actual lecture on what solid means. It's 5 principles, though. So it's 5 different things. But one of those is the S stands for single responsibility. So every class definition you have should only have one job. And think of it like at an institution. If you were hired at a company, you should only have one role that you do at that company. You shouldn't have to take on multiple diverse different roles. That doesn't make sense. And a lot of the reason why that doesn't make sense is it's hard for maintainability and accountability. One of the easiest ways to be able to maintain code and to ensure when something breaks where it likely broke at is by adhering to the concept that every code entity, every object inside of your code system has one job. And so instantly, if something's not working, you know which of the classes to go to try to root out the problem. So for instance, if I started to plague employee with also having to know how dates work, and all of a sudden the date wasn't working well, that's going to create a huge class. This class is going to be super convoluted and hard to maintain. You have to have lots of domain knowledges, like you have to know what an employee is modeling and how dates are modeled and all this other supplemental stuff that just makes understanding this code much more difficult. So yeah, if we want to make it more modular so we can reuse the date class, if we want to make it easier to be able to manage and identify where bugs are in our system, then every time we start seeing like collections of related data that has its own set of rules and modeling concepts, we want to pull that out and refactor it into its own class. And sometimes while you're initially doing your development work, while you're doing your initial architectural designs of your software system, you might not realize that you have this smaller constituent class that you have to model until you start defining these larger classes. So while defining our employee, we realized, hey, our employee needs to have this date. And so instead of defining it with the primitive data types, we would just create a new class and take advantage of composition, which Java allows us to. Okay. Let's see here. Let me actually, at this point, also just grab some of this pre-made code so I can just run through it. So I can actually get through this today. I find that I can, oh. Okay, so let's go here. I hate when it does this. There we go. Let's do. So let me go to GitLab. Let's see here. Okay. I want to say, okay. I say this was towards the tail end, not there. Was it the 26? Okay, yeah, perfect. Let's just download this as a zip. And then what I'll do here is I'll also make this available. There you go. I'll make this available inside the chat too for anyone who wants to see. And what I can actually also do here is let's go here. Nope, not there. Let's go here. Into my, no, let's go. No, I want to actually go. Yes, let's go there, there, and there. IDE, perfect, and refresher 1. Okay, let's go into our source code and let's cheat. Okay. Finder window. Let's go to my downloads. Let's grab, oh my God, my downloads. Okay, perfect. And whatever, I'll just grab all of this. Okay. And notice, oh, wait. How did it follow me along there? So I guess the chat box does follow me around? I want it back. Ah, is that? Yeah, that's great. So I can move between screens and have the chat box follow me. Oh, that's good to know. Okay, so notice now, as soon as I move external files into my source code directory, it'll just auto load, so I have access to them. So now I can just kind of highlight what's happening here and talk about the code so that we can guarantee that we get through this today. So well, let me get rid of, yeah. Let's get rid of all the date classes that somehow got pushed into the repository. Clean this up a little. Okay, perfect. So notice actually here that there's a couple things. They use different symbols here too that you can start to use to identify what's happening in your Java project. But let's continue where we last left off. So we're going to model a date as a set of 3 different attributes, right? A year, a month, and a day. And then we're going to create a constructor, right? that is going to go ahead and set the date for us, right? And notice, did you see that? I don't know if this was shown to you, but it's probably pretty obvious. You can call instance methods inside of your constructor if you wanted to, right? So notice here, I'm calling a instance method set date inside of my constructor instead of defining that directly. But the rule of thumb is if you do rely on instance methods to go ahead and set your instance variables, it should always be private. Now, here's a motivating question. Why do you think it should be private? So I have this set date method here, right? That takes in a day, a month, and a year, and it sets the year, it sets the month, and it sets each individual day. These are called helper methods, by the way. So again, one thing we strive to do is make our code as readable as possible. You should never make a method that's more than 10 or 12 lines of code. If it's that big, you should start breaking it down because you'll probably violate that single responsibility. So just like classes are supposed to represent one type of thing in your software system, each method should only have one action it does. And typically that action can either mutate a property of your class or it can return data, but it almost never does both. So typically the things that return data we call queries, the things that or getters, and the things that that mutate the class we call mutators or we call setters. And like we saw that the IDE calls them getters and setters. So why do you think I wouldn't want to make this public? And this is it's not very obvious. So yeah. So what'll happen is if it's public, then it exposes this method, right, to all of its inherited classes, right? So if I wanted to make some type of inherited class, if I wanted to make a subclass of date, I'd be able to potentially override that method, right? Because if I define a method with the same name and the same set of parameters inside of my subclass, then that's going to use that method in our subclass instead of our superclass. Now, if my superclass relies on that method to actually set its instance variables, and if my subclass has to invoke the parent class's constructor in order to build it, right? Then all of a sudden I could easily break this class. And actually that would violate another one of those solid principles we're talking about. That's actually the O of the solid. I'm really gonna have to do a lecture on solid. That's the open close principle, where your classes should be open for extension, but they should be closed for being able to like mutate how they actually operate at a fundamental level, right? So that's why we would list this as private. Anyway, jumping back to this, so we're going to have a set date method. Our set date method is going to call some helper methods where it's actually going to go ahead and set the year. And so set year is going to contain all the logic to determine if a year is valid or not. Set month is going to have all the logic that decides whether a month is valid or not. And set day is going to have all the logic on whether a day is valid or not, right? And so here, if I go to set year, and when you were doing your date method, is this something that you did in class where you checked to see if it was a valid value, and if it wasn't, you threw an exception? Has everyone seen this? So we'll check, for instance, inside of our private method set year, we're going to take in an integer, and if that integer value is less than 1900, then we're going to say, well, that's not what we consider to be a valid integer value for a year. So we're going to return back control to the invoking code, the client code, and we're going to create a new illegal argument exception. And that could take in a string, which is a message that will be delivered to the invoker, the client code, to this method. And if it isn't, if this if statement doesn't get triggered, then we'll just go ahead and set the year value. Okay, so you've seen this, but you haven't implemented it. Well, I kind of regret not doing it from scratch, but I think everyone is probably code literate enough to actually read all this. So the motivating factor behind what's happening here is that we're representing year with a primitive data type of integer, right? Now, it's important to note that what that integer is modeling is a subset of integers. So we can use an integer to go ahead and model a year, but it can't be any integer, right? The number of integer values is larger than the number of valid values that we want to use to represent a year. And so this is an important concept. This is one thing that really drives the idea of encapsulation. Did you kind of talk about encapsulation when talking about designing things with objects or with an object-oriented approach? Okay, good. Yeah. Encapsulation allows us to effectively hide our implementation details, but it also allows us to toggle our instance variables to be private. And the reason why our instance variables are always private is because we want to ensure that the only class that is allowed to mutate the state of them is the class that maintains it, right? So right now, we're putting in a lot of logic into defining what represents a valid date. And so you could potentially break what we consider a valid date if you use a integer value that's completely illegal. It's a legal integer value. Like it's a valid integer value, but it's not a valid year, or it's not a valid month, or it's not a valid day value. So we have to check whenever we go to set the value of year, month, or day to make sure it's valid before setting it. And if it's not valid, then we refuse to do it. And in fact, we throw an exception to our client, to the client code. So if you haven't seen this before, we'll look at this more so, looking at it now. So had you done any like try catch blocks in 1583? So the idea behind a throw, so there's two ways that you can return code back to a invoking method, to a client code. One is a return statement, the other is a throw statement. A return statement can return back whatever type data is declared inside of the method declaration, right? So if you're not returning any data back, you return back a void. If you return some type of data back, you declare that data type. So this returns back an integer. So if you have anything that's not a void in a method declaration, then it has to have a return statement that returns back that type of data. Like at compile time, Java validates that. Okay. A throw statement allows you to return back to a client, but it returns back a exception object. And an exception object can potentially be caught by the client code that is attempting to do this like really risky thing. Or if it doesn't try to catch it, you'll just go ahead and essentially you'll error out. Your program will exit out with some kind of exception code or error code. And then you'll get something that gets reported on the terminal that tells you what exception occurred. But the cool thing about exceptions is you can actually catch them and prevent that. You can respond to exceptions. And that's how you make more fault tolerant software. And so we'll look more at exception handling over the course of this semester as well. Like we'll have to, because there's things that are just intrinsically kind of like dangerous, or things that potentially could fail. And we might need to give a set of instructions on how to respond to that potential failure, that statement not doing what we would like it to do. So here, so let's go back here. So here, we'll just say the the year must be before 1900. Here for set month, what we'll do is we're going to check for the invalid cases, right? So if the month is less than 0 or the month is greater than 13, then we would throw, and then we're going to invoke a new illegal argument exception. And so notice I'm not doing any import here. So this means that an illegal argument exception, right? Those are implicitly imported for me along with my source code, just like the exception object or exception class. Okay, so if the month is negative, or if the month is 13, or if the month is higher than 13, then I'm going to go ahead and issue a throw new illegal argument exception. Okay, and now here I'm going to, for my set day, in order to set day, that's the most complicated of these, right? So I need to know what month it is to figure out what day it is, how many days is in here. And I even abstracted away trying to do Labor Day because I was live coding this in the classroom and I didn't feel like it was worth the additional 15 minutes to do that. But here we're just going to say we have a static attribute here that's also final, which is days per month. So you'll see at index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, right? I have 12 indexable months, and I just use as a placeholder my 0 there to go ahead and get what the max number of days is. So if the day is greater than that, or if it's 0 or less than, we throw a illegal argument exception day. So again, a big thing about what's happening here inside this class is our class only allows us to set each of these properties with a set method, because that allows us to control the logic by, it allows us to define what is a valid value that we're willing to set it as and what is an invalid value. And if it's an invalid value, we don't do it and throw an exception. And if it's a valid value, then we'll go ahead and set it. And then what this allows us to do is create a class that's very robust. It's very fault tolerant, and it won't allow other developers or yourself to potentially break your system by accidentally setting the date to a date it's not supposed to. And for some reason, if your code is doing that, it's alerting you. It's sending you an exception to say, hey, you're trying to create a day that's not considered valid. Then we have our get methods here. And then we have a toString that allows us to define the format of that. Okay. I'm going to move on from this. Is there any questions for the date, for this date class? This is just really, for the most part, a routine class file. So the only interesting thing here that you might not have seen is where we actually check in our setters to ensure that the data that's being passed in to set is valid, and not doing it if it's not. And again, that's really the motivating factor on why all of our instance variables are declared private, whereas our instance methods are declared public, because that's part of our API. That's part of the interface that client code sees. Like when I go and look at anything that I can do in Java, for instance, let's go and open up and let's go to that math for Java Oracle API, right? When I go and take a look at, and I'll use Java 17, the math class, this is the contract that I as a client form with the serving developer. So whoever created this created an API that says, hey, these are the public methods available in this class that you're allowed to invoke. This is the data that gets passed into it, and this is what it returns back, right? And so you can, from this class, it's letting me know these are all static too. So I can call these static methods, can be called directly from the class. So I don't have to create an instance of math. I can just type in math, then dot, and then any one of these names. And then I know I'm going to get returned back this value if I supply it this value. And how it works, I don't care, right? Like that's an awesome thing about encapsulation. Other developers don't have to know how you solve the problems. I just know what this description tells me, and that's all I care about. And like, yeah, if I want an absolute value, I don't want to know how it's done under the scenes. I just want to know that if I put my int value in there, it's going to return the absolute value of that. And so every developer that's developing a class, when you create a set of public methods, you're creating a contract with other classes that can access them, saying, this is what I will give you if you give me this data in. But then you have to abide by that contract. So if it's your class's responsibility to manage a valid date, then you have to make sure that you don't allow an invalid value to be used inside of the date. Okay, so let's now move on. So let's move on to our employee class. And so inside of our employee class, we're going to create a class employee. Ignore the implements payable right now. Initially, we just had an employee class when you probably did this, and you would have the first name, the last name, and the hire date. We would have the constructor, right, that allows us to take in our parameters and set our instance variables. We have our getters, and we have our toString method, and we have our, okay. So we'll have those. So initially, when we create an employee, that's what we decide. But if we're going to create an employee payment system, right, and we have to define, well, how's an employee going to get paid? Like how do we get the earnings of an employee, right? We can't just name that from the employee class, right? Because there's multiple ways an employee can get paid. An employee can get paid by commission. An employee could get paid hourly. An employee could get paid by salary, right? All of those are valid. So one way that I can go ahead and resolve this is I could create 3 different classes: a commission employee, an hourly employee, and a salary employee, right? And so I could do that. And so let's actually open those up. So if I create a salary employee would have a salary, and a salary employee would, let's see here. Okay, so whereas a hourly employee would have like an hourly rate and an hours worked, and a commission employee would have like a rate and their whatever their percentage rate is, and the sales of the rate that they're getting a percentage on. Now, what might happen, notice I started from like a top-down approach. I showed you the implementation of employee first, and then said, hey, if we're going to do a payment system, we need to know how this employee is getting its earnings. And then we recognize, oh, there's multiple ways that an employee can get earnings. And so so I might need 3 different employees. But in what also happens is that you actually create the hourly employee, salary employee, and the commission employee first, and then you see there's a lot of shared data, right? So you see where that might be a thing? Because again, I'm trying to highlight design concepts here. And one of the deficiencies is I'm showing you the finished code. So I'm trying to motivate some of the what the end results before we get there, which is unfortunate because we're already there. But the idea is that all employees, whether it's a commission employee, hourly employee, and salary employee, rely on this data, right? A first name, a last name, and a hire date, right? So I could have made commission employee, hourly employee, and salary employee their own independent thing, and they could all have their own first name, their own last name, and their own hire date. But a deficiency in that is I'm violating the dry principle, right? Now, all of a sudden, all of these 3 employees are duplicating these instance variables, which means that they're also duplicating these getter methods and these setter methods. So instead of duplicating these values across these 3 different employees, right, I can just extend from employee and create this abstract class employee. or just create an employee class. It could be a concrete class, but in this instance, it's an abstract class because we have the keyword abstract. And so any of the shared data that these three classes rely on can exist inside of employee. And then I explicitly say, I'm going to extend off of employee. So now that's the is a relationship. A commission employee is a type of employee. An hourly employee is a type of employee, and a salary employee is a type of base employee. Now, if I want to make my payment system, let's go to the payment system here. One thing I wanted to do about my payment system is I wanted to have well, I wish I had, I don't have an employee payment. Yeah. So one thing I wanted to do with my payment system is I want to mix my different subclasses like salary employee, hourly employee, and commission employee. And if I want to do that, then I need to be able to go ahead and view the method from the employee level. So it would be at this level here, the get earnings level. So if I don't know how get earnings works, but I want to treat everything as that more abstract entity, then I can create an abstract method, which is a method definition. So it's a method declaration, but it doesn't have a definition. So this isn't a fully implemented class anymore because it has at least one class that is abstract, which means the entire class has to go abstract. What it allows me to do is I can now call this method from the employee level. But now what I can't do is I can't ever instantiate the constructor of employee directly because it's not properly defined. So it's not a concrete class anymore. So the only way I can create an instance of employee is by extending it by a concrete class that comes behind it and actually implements that get earnings method. And so that get earnings method will define how you compute how much money they're making. So for the commission employee, it's the rate times the sales. For the hourly employee, it's the hourly rate times the hours worked. And for the salary employee, it's the whatever just the salary is. Now, the advantage of doing this is it gives me the ability to be polymorphic in my behavior, where I can create one entity, like one array that is of data type employee, and I can put all my employees into it. I can have methods that use the parameter type of employee, and I can pass any type of subclass into it, right? And since my employee is abstract, I can access that get earnings method, because one of the things is, in my earlier example here, the only method I can access when I'm treating it as object are those methods that are defined in class object. That's why toString is always defined in class object. That's why .equals is always defined in class object, is so that we always have access to those methods. And so if we want to have access to a particular method, but we don't want to be able to instantiate it directly, we can just implement it as abstract. That's the motivating goal of that. Now, if I have other things that have some shared behavior, but no shared properties, like commission employee, payments, hourly employee, and salary employee all had shared properties of first name, last name, and hire date. So that motivated the concept of using an abstract class. But if I had something like a, let me open it here, an invoice, which also costs the company money, that is nothing like an employee. Like the only similarity between an invoice and a employee is that they both cost the company money. So if I wanted to have a collection of payable things, that's when I would start to look at using an interface. I would say, for instance, create an interface. Let me show it. Payable, where an interface is literally what we call, well, it's our interface. It's our contract of methods that anything that's part of this interface would also have. And so an interface allows a collection of unrelated classes to be combined or grouped together for a particular purpose. So because they have a shared behavior. So the shared behavior between both employees and invoices is that they're payable things. And so we're going to create this abstract method that's going to be called get cost. So invoice here is a concrete class that implements payable. Now, one nice thing about an interface is we can implement any number of interfaces. So I can have, and I would do that as a comma separated pair here. So I can just keep putting commas and more interfaces. And then all I have to do, my contract with the interface is I have to implement off of this class, off of this method. I'm sorry, off of this method. So whenever I claim to implement an interface, I have to go in and actually define a method that will then go ahead and define a concrete value of get cost. And so I could do the same thing in employee. I can say employee implements this payable interface. And so what I can do here, I can kind of even cheat. I can say, oh, well, I know that the get cost of an employee is whatever their earnings is. So I'll just invoke earnings, right? So actually, this is a concrete method, but it's relying on invoking the abstract method, which has to be defined inside of all of my subclasses. But an advantage of doing it this way is that I don't have to have the get cost method inside of any of my subclasses. I just have to define the get earnings method. So if I actually go to my payment system here and run this, you could see just very quickly, and then we'll be done. I will create an invoice and save it as a payable thing. I will create a salary employee and save it as a payable data type. I'll create an hourly employee and save it as a payable data type. I'll create another hourly employee and save it as a payable data type. I'll create a commission employee and save it as a payable data type. I'll create an array and initialize that array with all my payable things. And notice this is a set of payables. So the only thing I can access is what's defined at that level, at that interface. So if I jump to payable at my interface, I see there's only one thing that I'm allowed to access according to like my API. It's get cost. So inside my payment system, I will iterate over all of my payable things. But I want to show I can still tell what the subclass is. So for each of my payable things using a for loop, if it's an instance of invoice, I'll cast it into an invoice and print it to show you I can access the subclass. But regardless of whether it's an employee or an invoice, what I'll do is I'm going to get from it its cost. And I will go ahead and sum that, and then I'll show what the entire payable value is. And let me just run this. So I'm going to hit the green arrow here, and I'm going to run this. And I want to show you that that will then allow me to, oh, hang on. Let me get rid of, can I just, yeah, remove that and remove that. Let me get rid of these things that aren't actually used, but got carried along. Okay, so let me go back here. Payment system, hit the green arrow, tell it to run. And there we go. We see that here on the instance that the subclass was an invoice, I could actually check that and display that. I can access, when I cast it as a subclass, I can then access any of its instance methods. But from the interface level, I can only do the get cost, but I can go ahead, produce the sum, and then show what the cost of the company is for all the payable things. I just also want to highlight, while in the IDE, I can very quickly see what my main methods are that have my main methods, what my interfaces are, what my concrete classes are, my abstract classes by the icon. My concrete classes are all blue. My abstract classes have like this little gray edges on it, right? You see the gray edges? My interface is green with an eye, and you can see the green arrow is indicated on those classes that have main methods. So again, I kind of want to slowly highlight some of these features that the IDE will provide to you that just makes it easier to start working on larger code bases. Okay, I'm sorry I went a little bit over. Is there any questions before I end this lecture? Excellent. Well, I will then just go ahead and leave everyone. I think you all have lab today, right? Is lab immediately after this class? Oh, it's at 12:50. Oh, for some reason I thought it was 12:30. Okay. Well, I wish you all a good day. What we will do tomorrow is pick up from here and pick up any questions we might have. I shared the link for where the source code is at. So I advocate that you like open it up in IntelliJ, look at it, decide if you have any questions about it. And what I might do is offer an easy challenge to everybody. I might do like an easy homework that's kind of based off these concepts just to make sure everyone's feeling comfortable about this. And I might go over another example that's similar, but then I want to go into Java docs and define our own API and what it means to design by contract, which is essentially what we're doing once we start defining things like interfaces and abstract classes and how that adheres to our solid principles. Okay, I will stop. Oops, I will end recording. I'll just end.